Welcome, ladies and gentlemen. So what I'd like to do is show you how to sketch a graph when you're given a quadratic in standard form. And you can see I have standard form written up here. And I'm basically going to use the formula for finding the axis of symmetry as well as finding the vertex when we're given an equation in standard form. Now, you could also complete the square and rewrite the equation in vertex form. That is definitely a very viable option. However, if you're having trouble completing the square or rewriting it in vertex form, or you're having some problems where you're just like, I just need to find the axis of symmetry in vertex, a lot of times just applying these formulas are going to be the quickest way to do that. So first thing we need to do is know what the formulas are. So this first one, I'm going to kind of write in the formulas and spend a lot of time on it. And for the other ones, I'll just kind of go a little bit quicker. So for a function, basically the axis of symmetry, here you have a function, the other ones we have equations. So the axis of symmetry for all quadratics in standard form is going to be a line x equals opposite of b divided by 2 times a. So in this example, I have opposite of b, which is going to be my -6, divided by 2 times a, which in this case is going to be 1. So you can see I basically have a 1 here is my a, and 6 is going to be my b. Therefore, this is going to equal x equals -3. Now, if I was going to sketch this graph, to sketch the axis of symmetry, remember that the axis of symmetry is a line. All right? So I'm going to go over to -3. 1, 2, 3. I'm going to scratch a nice little dotted line. OK? There's my axis of symmetry. Now, for the vertex, a lot of times this gets students a little bit confused because of the notation. But basically, the vertex is going to be, if you notice, if you remember when we were graphing, the axis of symmetry goes through the vertex. Therefore, the x-coordinate of the vertex lies on the axis of symmetry, or is the same as the axis of symmetry. Well, remember, the axis of symmetry, though, is a line. X equals -3. So the vertex is going to be opposite of b divided by 2a. And then you're going to evaluate the function for opposite of b divided by 2a. OK? So in this case, if I wanted to go ahead and find the vertex, basically all I'm simply going to do is take my function. All right, once I found my value of my axis of symmetry, I'm going to plug that value into my function. So I have f of -3 equals -3 squared plus 6 times -3 plus 9. Therefore, -3 squared is going to be a +9. 6 times -3 is going to be a -18 plus 9. Therefore, this equals 0. So therefore, the input value is -3. The output value is 0. You can think of those as coordinate points. Input would be x. Output would be y. But in this case, we're talking about a function. So it's going to have an x-axis and an f of x axis instead of y. However, the vertex is a coordinate point at -3, 0. So I'm going to go to my axis of symmetry. I'm going to see, all right, my vertex here is at 0, 3. Now, ladies and gentlemen, to evaluate the rest of the points, there's a couple ways we could go ahead and do this. For the first point, you can see that this function has a is equal to 1. And if you remember when we were graphing using vertex form, when a is equal to 1, there's no compression or stretching at all. So therefore, to evaluate the points, we know that it's going to have the same shape as the parent graph. A is positive, so it's going to open up. And if you remember just the general form of the graph, you can go over 1, up 1, over 2, up 4. 1, 2, 3, 4. And again, I'm using these points from knowing what the graph y equals x squared is, because that's when a is equal to 1 as well. So using the axis of symmetry, though, now, I can now plot the points on the opposite side, because remember, the symmetry is symmetrical, and then I can go ahead and graph. OK? Now, what I'll do for the other ones, though, is rather than using the compression and the stretching, I'm going to actually use a table of values to help me plot the graph. But this one, since a is equal to 1, I remembered back to my vertex form, there's no stretching or compressing. So it's over 1, up 1, over 2, up 4, over 3, up 9. And I got those values from the original table of the parent graph. All right, so now let's go and get into the next example. Oh, wait, I'm not done yet. Let's go and find out some information. I'm not sure what you're watching this video for. Determine the vertex, the max, the min, so forth. So you guys can see that this graph here has a minimum point at its vertex. So my vertex is going to be a minimum value. Also, if we're finding the domain, that's going to be all real numbers. The range, domain, remember, is the set of all x values. So all values, this graph is going to continue to expand, representing all the x coordinates. And the range is going to be the set of all y values. So the lowest y coordinate that I have is going to be 0, which is included. And then it's going to go up to infinity. Infinity is never included, so we're going to use a parenthesis. All right, so now let's get on to the next one. On this next example here, basically to find the axis of symmetry, I'm just going to use a big capital A. I'm going to have x, again, equals opposite of b, which is positive 12, times 2 times 6, right, because it's opposite of b. So in this case, I'm going to have my axis of symmetry is 1. So x equals 1. So go ahead and graph that. I'm going to go over to 1, and I'm going to draw a nice little dotted line. All right. To find the vertex, now a lot of times this confuses some students, especially when I start talking about the vertex here, because with functions we can use function notation. F of that value, you plug that value in. But for the vertex, I'm going to use a table because these last ones I'm using an equation. And even though you really are applying the exact same process, the notation and everything is a little bit different. To find the vertex, we know that the x-coordinate of the vertex is still going to be 1. So let's go and look at a table here real quick. If I was going to make a table of values, x values and y values. If I was going to say that the the x value of one of my points is 1, to find the y value, what I simply need to do is plug 1 in for x and solve. It's just like what we did over here. It's just a little bit different notation. So all I'm simply going to do for my vertex is say y equals negative 6 times 1 squared minus 12 times 1 minus 1. Well, 1 squared is 1, so that's negative 6 minus 12 minus 1. So that gives me a negative 19. All right, so if you can see I'm going by 1s here, now I'm going to go by 5s. Negative 5, negative 10, negative 15, negative 20. Because obviously my graph's going to go really far down if I'm only going by 1s. So if I evaluate for my point here, so now I found my vertex, which has a negative 19 right there. Now, to find my other points, basically what I simply need to do is I need to pick points that are to the left, or did I do something wrong? Positive 1. X is equal to 1. Plug in 1, 1 squared, negative 1. Negative 19. OK. All right. So now I basically just need to pick points to the left or to the right of my values. Opposite. Oh, I knew I forgot something. The axis of symmetry is at negative 1. I knew I was making a mistake. I was like, man, what am I doing? It's opposite of b, which is 12, times 2 times a. A is negative 6. I didn't see that. My apologies. So therefore, this is actually at negative 1. So if I was going to go back to this, negative 1, got to be really careful. All right, so if I plug in a negative 1 now, let's double check my work here. Negative 1 still squared, that's still negative 6. Now that becomes a positive 12 minus 1. So therefore I get 6, now I get 5. OK. So I have positive 1, 5. So over 1, now up 5. 1, 2, 3, 4, 5. So now I can go by 5s. OK. That makes me a little bit better because I started doing the next couple points and I was like, I'm getting lost. So we found our vertex. Here is our vertex. And here's our axis of symmetry. Now remember, our axis of symmetry and our vertex share the same x-coordinate. Now to find the other points, unfortunately our a, we know that it's negative, so we know the graph is going to be opening down. Here it's positive, it's opening up. The other issue is we have this being multiplied by 6, so there's going to be some extreme compression, some horizontal compression or vertical stretching going on. So we can't just use our standard over 1, up 1, over 2, up 2, or it'd be down, right? Over 1, down 1, over 2, down 4. I have to go and apply the compression. And you can easily do that using the same type of method. But a lot of times it's much easier just to plug in 2 points to the right or to the left and find out what their coordinates are. So if I do y equals negative 6 times 0 squared minus 12 times 0 minus 1. Well, that's simply just going to give me negative 1. So at 0, I'm at negative 1. And at 1, I'm at y equals negative 6 times 1 squared minus 12 times 1 minus 1, which was negative 19. So at 0, I'm at negative 1. And at positive 1, I'm all the way down here. OK? Then all I simply need to do is reflect about my axis of symmetry. And you can see that this graph is much skinnier than the last one I drove because that 6 is compressing, horizontally compressing the graph or vertically stretching the graph. Let me use a different color. How does that sound? Oops. That's a horrible graph. There you go. The graph should look something like that, something around there. Really bad, but. All right, so now let's go ahead and move on to the next one, next couple graphs. So again, here, I'll have to be a little bit more careful. Again, we're going to be finding the axis symmetry. Axis symmetry in this case is going to be opposite of b, which is -2, divided by 2 times a, which is +1/2. Therefore, it's -2/1, which equals -2. So again, that's x equals -2. So to graph that, I'm going to go now over to -2 and draw a nice little dashed line. To find the vertex, again, if you noticed what I did in the last example, is I know that the axis symmetry, the vertex has the same value as axis symmetry. I just plug that value in to find x. So my vertex, I'm basically just going to take my equation, y equals 1/2 times -2 squared plus 2 times -2 minus 6. So I have -2 squared is going to be +4. +4 times 1/2 is 2, minus 4 minus 6. So therefore, that's going to equal -8. So my vertex, I forgot to go over that one. So my vertex in this case is going to be at -2, -8. So I go over 2, now down 8. 1, 2, 3, 4, 5, 6, 7, 8. OK? Again, another thing to kind of look at with this one is now we just need to pick out 2 more points, either to the right or to the left, and just plug them in. We know that since my a is 1, it's technically going to be over 1. Instead of going up 1, it's going to be over up 1/2. But let's just go ahead and take a look. What I usually like to do is I always like to choose values that when I square them are going to be divisible by 2. And so I really don't like dealing with fractions. So what I'll do is, never mind. Let's just do the next 2 points. Let's do -1 and let's do 0. So if I do -1, so basically I'm going to create a table, and I'm going to do these in my head to save a little time. I'm basically going to create a table. I know that my vertex is at -2. 8. And I just want to find 2 points to the right of that graph, because then I can use the axis symmetry to reflect about. So if I was going to do -1, I had -1 squared is 1. 1 times 1/2 is 1/2. 2 times -1 is going to be -2. -2 minus 6 is going to be -8. However, that's going to be plus 1/2, so that's going to be -7.5. So I go over, and then I go down 7.5, so halfway in between. Then, so that's going to be -7.5. Then let's do 0. Well, that's 0, so it's -6. So at 0, I'm down to -6. 1, 2, 3, 4, 5, 6. Now, I simply just need to reflect these points over. And now I can graph. And hopefully what you see here is that this a, since it's 1/2, that has stretched the graph horizontally or vertically shrunk the graph. All right, so next thing is now we're going to look at one last example. Oh, before I get to long, let's go and take a look at the domain and range again. So the domain and range, remember the domain is the set of all x values. Well, guess what? For all quadratics, it's going to be all real numbers. I'm going to write it a little bit differently this time. I'm just going to write from -infinity to infinity, whereas the range is going to be the set of all y values. Well, here the lowest value was 0. Here the lowest value is going to keep on going down to -infinity. So it's going to be to -infinity. And then here the highest value is infinity. Well, here the highest value is +5. And that's included. Now my vertex, which I also wrote, is -1, 5. You can see that that is the highest point. So I'm going to write that as a max. Whereas over here, my vertex is the lowest point. So that is a minimum value. The domain of this is going to be all real numbers. So again, I could write that as -infinity is less than x, which is less than infinity. My range, the lowest value here, is going to be at my y-coordinate of my vertex. So that's going to be at -8, which is less than or equal to x, which is less than infinity. I'm sorry, not x, that's y. So just kind of notice the difference here for your range. Domain, you're dealing with x. Range, you're dealing with y. These are all just kind of 3 different ways you can write domain and range. So I wanted to present them to you because you might see something different depending on what type of assessment you're taking. All right, for the last one, I have y equals negative 3/4 x squared plus 6x plus 1. All right, so in this example, basically what we're going to do is do the exact same thing. All right, so the axis of symmetry is going to be opposite of b, or I'm sorry, x equals. Did I write that in there? No, I didn't. All right, so it's going to be x equals opposite of b, which is opposite of negative 6, divided by 2 times negative 3/4. This does not look like fun, does it? So the negative divided negative is going to make it positive. So it's going to be 6 over. Now 2 over 4 can basically, that can be simplified. I can reduce that over 1. So I can reduce that to a 3/2. Now, whenever you have a number divided by a fraction, just multiply by the reciprocal on the top and the bottom. So that becomes 2/3 over 2/3. And what I get is going to be 12 over 3, which equals 4. So therefore, the axis of symmetry is x equals 4. So going to my graph here, I'm going to go over 4. 1, 2, 3, 4. I'm going to create a nice little dashed line. All right, so to find the vertex, again, now I need to plug in that x value into the equation to find my y value. So I'll have y equals negative 3/4 times 4 squared plus 6 times 4 plus 1. So 4 squared is going to be 16. 16 times 3/4, 16 divides into 4, 4. So that becomes a negative 12 plus 24 plus 1. So therefore, that gives me 13. So therefore, my vertex is at the coordinate point 4, 13. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So way high up there. There's my vertex. So you can see that vertex, since it's negative, I know the graph is going to open down. So therefore, my vertex is going to be a maximum point. All right. So now, again, all we simply need to do is just find 2 points to the left or to the right. Now, since the graph is going down, I would prefer that you choose, you could just, I always like to choose points that are right next to the axis of symmetry. It makes it easy. However, if I choose 3 and I do 3 squared, that's going to give me 9, right? Well, 9 times negative 3/4 is not going to give me a nice little fraction because 4 doesn't divide into 9. So what I'm going to do is a little bit a different method. I am going to choose values that when I square them, they are divisible by 4. So if I'm still looking at choosing 2 points to the left, 2 points I could choose would be 2 and 0. And 0 is always a great number to use, as long as your axis of symmetry is relatively close to 0. So if I plug in 2, I get 2 squared, which is 4. Well, 4 times negative 3/4, the 4's divide out, so I'm just left with negative 3. 2 times 6 is going to be 12, plus 1 is be 13. So it would be 13 minus 3, which is going to be 10. So at 2, I go up to 10. At 2, I'm at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 0 is always a great one to see, because at 0, those go to 0, those go to 0, and you're just left with 1. So at 0, we are at the point 1. Then all I simply need to do is just so you can see